Good Wednesday evening, everybody. This is your favorite sportscaster, Yam, coming to you from well, it doesn't matter where. Okay, so in this screencast, we're going to talk about our continued journey in integration. And what I'm going to do here is I'm just going to go ahead and pull this one to the side when we talk about it. So let's just do a little bit of a recap. And it's important just to kind of have a revisit every time we learn something new. So let's just, when we talk about integration, okay, or anti-differentiating, what we have been working on is recognizing derivative rules in reverse. That was step one. Then we talked about separation of variables, a particular technique when you have a dy dx, that's in terms of x and y, and you are asked to anti-differentiate there. And generally speaking, you will separate variables when you have a relation, not always, but sometimes, right? That's when we see it the most. Now we're going to talk about another integration method. So, these integration methods, there are far and wide, and they are as expensive as your methods of taking the derivative were. And what I'm going to do here is walk through with you your next method of anti-differentiating, your next method of integrating. And we're going to look here at this integral right here, okay? So this is the antiderivative of x over the root of 4 minus 5x squared dx. I want you to very quickly go through kind of your triage, right? When you look at this, clearly there is no derivative rule that even remotely looks like that, looks like this integrand. So looking for the derivative rule in reverse is absolutely out. What I want to do here is just show you the steps that I'm going to work through, and then we're going to go back and revisit those steps and talk about what I did, how I made some really important choices, and then move forward. So this is a little bit backwards from how I typically teach new content, where I don't usually just say, just watch me do this. You're gonna watch me work through steps, and then we're gonna go back and talk about it. So what I'm noticing here is this integral is in terms of x. So an integral in terms of x really says a lot of things. An integral in terms of x tells you the dummy is x and also the integrand's in terms of x. I'm going to go down here and say this. I'm going to say let u equal 4 minus 5x squared, okay? I'm going to choose u to equal 4 minus 5x squared. And the natural question I hope many of you have is, well, how the heck did you choose u? Why couldn't u have been x? Or why couldn't have been u been the square root of 4 minus 5x squared? We'll talk about all those in a second. And then what I'm going to do here is take the derivative of u equals 4 minus 5x squared, and I'm going to use correct differential notation. So if I take the derivative of u equals 4 minus 5x squared, the correct differential notation is d blank over d blank. It's going to be du over dx equals negative 10x. And then what I want you to do here is take this equation, this differential equation, and I want to solve this for dx, which means get dx by itself, okay? And you're going to see I got this. dx is going to equal du over negative 10x, okay? It's just algebra. And now here's what I'm going to do. I'm going to walk back to my original integral, and I'm going to substitute in u, and I'm going to substitute in dx. So watch, here's what we're going to do. Ready? It's going to feel clumsy the first time around, but all things feel clumsy the first time around. The indefinite integral didn't touch the x over the square root of, I called the radicand u, here we go, times, here is, right, the sub for dx, du over negative 10x. And now what I've done is I've substituted everything back into my integral. And hopefully you are very disturbed because a cardinal rule has been violated. The dummy has been changed to u, but the integrand is not only in terms of u. Oh, but you say this. Antiderivative of, I'm going to call it negative 1 over 10 root u du. So here's what just happened. I just took an integral in terms of x, and I rewrote it as a simpler integral in terms of u. I effectively changed the variable of integration, thereby simplifying my integral. My choice of u was critical. My choice of u was critical because when I then took that equation and took the derivative and solved for dx and subbed everything back into the integrand, after simplifying, I get this lovely integral right here. Ladies and gentlemen, would you please go and anti-differentiate this integral? This is old news. This is old news, okay? We did this 2 days ago. This is really the indefinite integral of negative 1/10 u to the negative 1/2 du. Go ahead and anti-differentiate that and meet me there, okay? If I anti-differentiate this correctly, I'm going to get u to the 1/2 as a power, right? Add 1 to the exponent, and this is going to become negative 1/5. Everyone okay? Very good. Oh, plus c, yam. Plus c, yam. Come on. And what I've just done, everyone, is I have just anti-differentiated. There's a big but. But generally speaking, it is always best to express your final answer in terms of the original variable in question. The original integral was in terms of x. So I would like to express my antiderivative in terms of x. I wish I knew what u was. I do. U is right here. At the end of the day, my antiderivative is this. And there it is. Okay? This method of integration is called, no surprise, it's called u substitution, or u sub. This is called integrating by u substitution. Okay, now let's talk about how I chose u, integrating by u sub. This is this method. So unfortunately in calculus, there are no rules that hold all of the time. I mean, I guess you could be very argumentative with me and say, well, Ms. Yam, calculus includes all of math, and doesn't 1 + 1 = 2 all the time? And yes, I'll give you that right now, but actually, if you take math in about 4 years, you will learn that 1 + 1 = 2 really isn't a fact. It's more of an opinion that has been just verified over and over again. But enough of that. So what's interesting to me here is, in this case, so the examples you're going to do tonight, by and large, you're going to notice something. You're going to notice that, for the most part, our choice of u, that which we chose to be u, is some inner function. Meaning, if I look at this integrand, x over the square root of 4 minus 5x squared, right here I see a composition of functions. I see a square root of 4 minus 5x squared, okay? So if you want to, the easy and absolutely unsatisfactory explanation is, much of the time, but much of the time is just north of 50%, much of the time the choice of u is some inner function, okay? Here's the more robust explanation. When you are using u substitution, a very good visual check at this juncture, which is the very, very beginning, because believe it or not, very soon you'll be able to integrate by u sub in your head. A very good visual check is to see if your choice of u and your choice of the corresponding du by dx, right? If your choice of u and then the resulting du by dx, I'm going to change color so you can see here. A good barometer is to say, does u and du dx account for everything in the integrand except for a positive constant that is introduced along the way? One more time. Does our choice of u and the corresponding du dx account for every variable expression in the integrand, give or take a constant factor which doesn't disturb us? The answer here is yes. Take a look. 4 minus 5x squared accounts for this part of the integrand. The x here accounts for this part of the integrand. The fact that there's a constant factor introduced into the mix doesn't harm me, because if there's a constant factor, look where it lands. Somehow it just lands as a factor of the integrand, which doesn't prevent us from using a derivative rule in reverse. Okay? I said that the choice of u is an inner function much of the time, 50%. And then I said a little bit more robust is thinking about whether u and du dx account for the integrand, give or take a constant. I'm going to say that's about like 85 to 90% of the time. The remaining times, it is like just experience and trial until you figure it out. Okay, so are there some times when u sub can get really hairy? Absolutely there are. You won't see those tonight though. Let's try another one together. Let's try one from your homework. I think I assigned 21 through 31 odd. Let's just do 21. Let's do 21 and let's do, well, dag knobby. Let's do 21 and 27, okay? So 21, I'm going to meet you there. The indefinite integral of e to the 2x dx, okay? So here, let's see, e to the 2x. There's two functions going on. There's an exponentiation to a base of e, and then there's kind of an inner function of 2x, right? Let's just see what happens if we let u equal 2x. Let's let u equal 2x, okay? Now I'm going to take the derivative. Du by dx just equals 2. When I solve for dx, I get dx equals du over 2. Let's shove everything back into the integral now. Indefinite integral of e to the u, okay, the dx is now du over 2. Oh, look at that. I generally like to take one additional step and make this look nice. Indefinite integral of e to the u over 1 over 2, or just 1/2 e to the u du. And what does this equal? What's the antiderivative of e to the u du? It's just e to the u. So 1/2 e to the u plus c. Let's express the final answer in terms of x, which is ideal. 1/2 e to the, what's u again? 2x plus c. Well done. Good. Go ahead and do, you know what I want you to do? Do 27 and then do 37 on your own, then replay me. I know 37 was not asked for homework, but you know what? I want you to try it. Go ahead. Try them and then replay me for the answer. 27, 37. Okay, number 27. We've got kind of an inner function situation going on again, right? 6 over some inner function raised to the third. Let's see what happens. Let's let u equal that inner. Here's du by dx. Solving for dx. Subbing back into the integral. Cleaning, very happy here. Antiderivative in terms of x. Boom. 37, little juicy one here. Interesting, right? There is an inner function. I mean, my eye always looks at the inner function if there is one, right? 5 over x, which I rewrote as u equals 5x to the negative first. And after you choose your u, it's just procedural, right? U equals 5x to the negative first. Here's my du dx, being really careful here. Solving for dx, watch your algebra here. Subbing it all back in, really happy because look what happens. The x squareds cancel. I'm right here. I'm right here. Boom, done. All right? So my question to you all is, u sub, integration by u sub, is the reversal of what derivative rule, everyone? It's the reversal of what? What? Yes, it's the reversal of the chain rule. It is the reversal of the chain rule, okay? Listen, really important, your first time doing u sub, you may try a u, right? You may try a u for a problem and you get to this place here where you simplify and it doesn't work. How do you know it doesn't work? There's like an x left over in your integral that's supposed to be in terms of u. It is normal to be frustrated and be like, oh, this stinks, you know? It's the first day. Give yourself a chance, all right? Go ahead and finish the homework. You should be all set. Great job, everyone. Goodbye.